All right, here we go. Welcome to lesson 10.4 Geometry Notes, Inscribed Angles and Polygons. So, um, yeah, we'll jump in here. We'll talk define inscribed angles. Look at how does that relate to arc measure, which was covered in the previous lesson. And second half is looking at those inscribed polygons, but then specifically quadrilaterals. So let's do it. Let's get it done. So first thing, we defined in class what is an inscribed angle. We can leave the picture, I guess, here. It's kind of all fits together. So different than what we had done in the previous lesson, 10.2, that a central angle had the vertex on the center of a circle. Our inscribed angle has the vertex on the circle itself. So we could put some put some points here. We can call this point A, point B, and point C. So our inscribed angle vertex on the circle, and then the sides, essentially we could say almost just intersect the circle. And then in doing that, where we intersect here at points B and C, we create what's called an intercepted arc. So there's a little bit, there's inscribed, intercepted, kind of some words there sound the same, but so this intercepted arc, it's a little bit kind of a fancy definition. The arc that lies in the interior of the inscribed angle, which I guess that makes sense. This part here then has endpoints on the angle, is called the intercepted arc of the angle. So kind of long story short, when we draw or we see an inscribed angle, that arc that's kind of formed on the interior of the angle, that's what we call an intercepted arc. All right, so that's some of the vocab. Here's the big reveal, basically. What's the relationship? If we're comparing this to 10.2, if we just seen it here, just as a very quick recap, kind of side by side, we saw that when the central angle, let's just say was 75 degrees, then the arc measure, the measure of arc AB was also 75 degrees. Okay. Not quite the same here. All right, so it's a different relationship. That was 10.2, 10.4. Here it is. The arc measure of an inscribed angle. So that same, very similar picture that we just had here. Here's my inscribed angle. Vertex D is on the circle. We're extending the sides through the circle, hitting here and here, and we create this, what we're calling as an intercepted arc, arc AB. The measure of the angle ADB, is half the measure of the intercepted arc. Okay, so if the arc measure is 100, the angle measure is 50. The other way to say it, which we did write in class, was that the arc measure, the intercepted arc measure, is twice or 2 times larger than the angle measure. So again, if I knew this was a 70-degree angle, we would know that the arc measure of AB is, 140 degrees. So that's kind of it. That's the big reveal. That's the concept that kind of is at play at a lot of what we do in this lesson. As always, let's run through some different looks, some examples. These are ones that I know in class. It wasn't as such a high percentage of students hitting all these ones. So make sure we go through, we do it. You try them first, and then we'll go through the solution right now. So let's see what we got. Find the indicated measure in circle P. One thing that's definitely different than the previous lesson, most of the time it was almost always find the arc measure, find the arc measure, find the arc measure. Going, well, we're not necessarily the other direction, but also we're in this lesson, we're finding angle measures. That's an angle, the measure of angle S, and then we're back to the measure of arc RQ. So I think where sometimes students struggle is just understanding and knowing like what they're looking for. So if I kind of highlight these, where is the angle S here? When it's asking about the measure of angle S, we're talking about that angle measure here. And then let's switch colors here. For the measure of arc RQ, we're talking about the arc measure up here. So those are the two things we're looking for. Most people did fine with the measure of angle S, seeing that, hey, I've got an arc right here that arc RT measures 60 degrees. So to work backwards and figure out what this angle measure is, I need to cut that arc measure in half and say, oh, okay, the measure of angle S, that's 30 degrees. Okay, so that's what we should have got for the measure of angle S. Now, how are we going to get over to RQ here? Just kind of looking at it, I don't see an angle that's necessarily intercepting or, creating that intercepted arc. Now I got this 37 here. What's going on here? This angle right here, QRS, is creating, it's an inscribed angle, forming arc QS. So now going this way from the angle measure back out to the arc, I am going to double it. So we're talking 74 degrees here. That's not what it asks us to find, but I think it's something we're gonna use. I think the other just big thing that we need to see here is that I've got segment RS, which is a diameter. We saw that in the previous lesson. That, oh, hey, because that's a diameter, I know this semicircle from here to here must measure 180 degrees. So therefore, I can go, 180 minus our 74 that we figured out was the measure of arc QS and say, oh, okay, I got it. The measure of arc RQ has got to be 106. So a little tougher there, I think, for the second one, for part B. That's where we should end up. Could we have found, I know it didn't ask, could we find this one down here if we wanted to? Sure. Same logic, that we've got another semicircle here. So I could go 180 minus 60 and say this is 120. It didn't ask, but it very well could have. Oh, look at all that marking. Looks crazy. So hopefully you follow there. Jump right into example 2, which will lead into our next kind of shorter note. All right, what are we looking for? Find the measure. You pause it, you start it, you try it. Find the measure of arc HJ. Where is that? So at one point, we're going to have to try to find this measure. And then we're also, let's set that up, the measure of arc HJ. And then just, why not? We're here, the measure of angle. So it's kind of similar to the last one in that it's asking for both an arc and an angle measure. Where is that? HGJ. So we're looking for that one there. All right, what's the game plan? So I see this here is that, it's tough because you got to kind of be able to sift through and just focus on one thing at a time. I see this inscribed angle of 39 degrees forming arc, intercepted arc HJ. So when I move out from the 39 to the arc measure, we know, hey, I got to double that. We should be getting 78 degrees for the measure of arc HJ. So we can put that on there if we want, times 2. All right, so far so good. I'm on board with that. I guess why wouldn't I be? I did it. And then now, here's the thing. Well, how am I going to work over here? Well, take a look. This angle HGJ is also intercepting. Whoops, kind of got the pen got off a little bit here. Arc HJ. So the same arc 78 that we just figured out, I can work that number backwards by dividing by 2 or multiplying by 1/2 and say, hey, 78, what's half of 78? Oh, it's already on the paper. It's 39. 39 degrees. So the follow-up question we can just kind of verbally talk through is, what do you notice about that, what we just found, angle HGJ and angle HFJ? Well, I didn't put it back in there, but these are both 39. Is that a coincidence? No, of course not. They're both intercepting the same arc, right? HJ, that's 78. So whether I work that 78 and half back this way, or whether I work that 78 back in half this way, it's 78 divided by 2 is 39, right? So that's actually a theorem. Let's take a look at here. That kind of just leads right into the next note. We call it in class, as far as a heading, 2 inscribed angles intercepting the same arc. So we kind of just wrote the theorem as like a heading, and then we kind of just made the picture. So yeah, that's it. What we're kind of looking for is this hourglass figure It can be, this is more like pretty square up hourglass. It can be kind of skewed a little bit, but that's what we'd be looking for. So, yeah. All right, so there was the theorem. Kind of a short, quick example here. Example 3, we're doing all right. Look at that. I can see the end. Holy cow. Name 2 pairs of congruent angles in the figure. So I see it, it's rotated, right? The hourglass is kind of on its side, but it's going to be the ones that are same side. So like angle P and angle Q, where's the arc that they're both intercepting? Right here, right? So, yep, that angle, and you could go through it. I'm not saying you have to, but both of those angles, if I were to kind of sketch the sides of them, create this arc RS. So angle P would have to be congruent to angle Q. And it actually works the other way too, that if I start here at, put S as my vertex, angle PSQ forms that arc, and then angle QRP is also creating arc PQ. So it's the same deal going this way, that angle S would be congruent to angle R. All right. So other than that, numbers-wise, there's nothing there. We could see it. We saw it in the previous one, with numbers, where we might find some angle measures. All right, let's try to finish this up. Last kind of big concept here. That was kind of the first half of the lesson, inscribed angles. The second half, focus on what we're calling inscribed polygons. Okay, so kind of simple in that it's a polygon with its vertices on the circle. Okay, so here you can see we've got a triangle. As far as there's the vertex, 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 they're all on the circle. You could do this with any figure. We've got a quadrilateral here, 4 vertices. Really, all you have to do is draw a circle, and whatever kind of polygon you want to put in there, draw that many vertices. 1, 2, 3, 4, 5, 6. Okay, connect them all, in order. There we go. I've got an inscribed hexagon. So. We didn't really do much with this. With the circle itself is what's called a circumscribed circle. We didn't add that. We just really have to know that it has to do with circumference, and we did the circumcenter that involves, the circle. But yeah, we just knowing that when we put a polygon inside there, we call that an inscribed polygon is kind of what we need to recognize. The last theorem for our notes here focuses specifically on quadrilaterals. So if we look here, first off, it says only certain quadrilaterals can be inscribed. Okay, so one thing I know that comes up is, well, what about a parallelogram? If I say, here's a circle, I want you to inscribe a parallelogram, like kind of a traditional parallelogram, the problem is going to be what? There's my parallelogram. That doesn't really kind of line up with my circle. I could get 2 of the vertices to work, but the other 2 are completely off. And so it's just going to work that way, that not every quadrilateral can be inscribed. But what this theorem says then, that if a quadrilateral can be inscribed, then we would know for a fact that the opposite angles would be supplementary. I don't know if this page lines up with the current textbook, so I'm going to get that out of there. Should have took it off before, but anyway, so the measures, so the measure of angle F plus the measure of angle D would be 180, and the measure of angle E plus the measure of angle G would also equal 180 degrees. So that's the second kind of big reveal here that we need to see. All right, we'll look at this concept along with just review some of the earlier ones here. I've got 4 or 3, just hopefully kind of shorter. So some of them are really quick, some are a little bit tougher examples here that we'll run through, and you kind of jump around and try the ones that maybe look the toughest. So here we go. You pause it, you sketch it, you try it. Here's the solution. So with part A, I see this. One thing that stands out, and you'll see it's very recognizable. When I see that segment AB passing through the center there, that like triggers in me at least, like, hey, I see that as a semicircle, and it is. It's like that is a semicircle. That's 180 degrees. So I like to get other numbers on the page there, right? 180 degrees. Okay, cool. This one's kind of tough to see in that, all right, here's a vertex. Here's point C, and if I extend the sides of this angle ACB, I see that those sides intersect, right, both at points A and B. which align with that intercepted arc, arc AB. So this is actually kind of from the first half of the lesson, that 180, if I want to work that back to the angle, the inscribed angle, what do we do with it? We cut it in half. So that's telling me that the measure of angle C equals 90 degrees. It's a right angle. Okay, so the finish then, once I know that, like, oh, hey, that's a right angle right there, well, 2x would have to equal 90 degrees, and that ends up being kind of a nice finish then. Just divide both sides by 2 to get 45 degrees. All right, so that one's maybe a little bit tougher as far as seeing all that stuff. Part B, hopefully, is one that, yeah, all right, we can do that one. This one is one that I wouldn't expect a ton of work. It's really it's opposite angles. It's a quadrilateral 1, 2, 3, 4. So we got 4 vertices, 4 sides. It's a quadrilateral. Inscribed. The property that we just looked at said opposite angles are supplementary. So y would have to equal 60 degrees because 60 plus 20 is 180. And then z would have to equal 100 because 100 plus 80 is 180. So we're going, it's cross. They're not the same. They're not congruent. They're supplementary. All right. All right. I think both of these involve quadrilaterals here. So we can hopefully go through these same type of thing relatively quickly, in that if I'm adding my opposite angles, 88, if you wanted to set it up, you could go x plus 88 equals 180. Although I know a lot of us are just saying, hey, you know what? I can go 180 minus 88 on my calculator. 92 would be x, and then going the other way, almost like the last one. So I know we kind of just jumped in there and did that one. I'm hoping you had a chance to kind of pause it and try it. Second one, a little bit more. So this is one that I would probably expect a little bit of work. If I'm going opposite angles, same thing's true, quadrilateral. Okay. 3y plus 3y has to equal 180. We're just setting it up a little bit more algebraically. So 6y equals 180. We'll divide both sides by 6 to get y equals 30. All right, one more here this way. 8x plus 4x equals 180. 12x equals 180. And divide by 12, I think we got 15 on that one. All right, so those are all kind of involving the same concept. Last set here, I think it finishes with one of the tougher ones. So we'll look at them both here. Pause it, sketch it, give it a shot. This one's similar to one that we did a couple ago, in that the first thing that jumps out at me is I see this as, hey, there's a diameter there. There's a semicircle. That's 180 degrees. So I can work that back to the angle, right? This angle y is forming that. So I cut that in half. I could say kind of the same thing, that 90, or like that has to equal 3x. 3x has to equal 90. That's a right angle right there. So again, it's that same finish. X would have to equal 30. And then most people in class, the way we did it, you can do more stuff with arcs here, but the fact that we know this is 90, we had a given that this was 34, a lot of people just said, hey, you know what? I can go 90 minus 34 and just say that this is a 56 degree angle, and then just finish it kind of the same way, that 2y would have to equal 56. So divide both sides by 2 to get 28. All right, last one. Definitely, I would say the toughest one on here. So when I look at this, I see the 87 inscribed angle. I want to double that and turn this into 174, I think, if we double that. Okay. Why? Well, we're not there yet, but if I start looking at this now, the other number that I know, this 27, which is this angle, same idea, that when I double that, I can get this arc measure out here at 54 degrees. And then the only thing we're missing are these two little pieces of the circle right here, this 2x and this x, which is what we're looking for. And what do we know about the whole circle itself? 360. So that's kind of where this one goes. X right here, plus this 2x, plus the 54, plus the 174, all have to add up to 360. So 3x, we'll finish it up here, 128. Whoops, not equals. adds up to, or plus, sorry, 120. Geez Louise, struggling here. I'm trying to finish it. Keep it short, keep it under a half hour is usually my goal. 228 equals 360. We'll subtract that 228 and get 132. Divide both sides by 3 to get x equals 44. So yeah, that one's tough. You got to see those arcs there. It was that bow tie one, or I'm sorry, the hourglass. So 87 and 87. You could also kind of do some stuff there with 27 and 27. So wow, that's it. Kind of went quick, but also a few. Getting through all the examples there. There's some tougher ones. So that's 10.4. I think we can call it there. I think we hit all the big ideas. I'm comfortable calling it. So that's all I got for you. I'll see you in future lessons.